Hi, Tim Skell here, Global HVACR Application Engineering Manager. Today we're going to take a look at the ACH580, ACH180, and EC Titanium. We have three different drive solutions, and we're going to take a look at those and do a compare and contrast. As we look to compare and contrast those drives, we're going to start with product introductions, then look at the hardware differences, review that user experience, talk about features, look at the application and installation of those drives, and wrap it up with a discussion on replacement parts and warranty. We've got the three different drives we're going to talk about, starting with the ACH580. That is the main flagship HVAC drive you're going to see in the industry. It's by far the most flexible of the drives we're going to talk about today as far as packaging, what power options are in it, what enclosure ratings it has, how much input and output it's got, what protocols it can communicate, like BACnet IP for your building automation integration. It's fully compatible with the EC Titanium motor, which we're going to talk about in a bit. And from a horsepower kilowatt capacity aspect, this can go from a very small motor to hundreds of horsepower, hundreds of kilowatts. So it's beyond just small fans. This does fans, pumps, compressors through a wide horsepower range. Then in the middle here, we've got the ACH180. This is often called a micro drive or a compact drive. It's going to have a little bit less I/O capabilities as far as inputs and outputs. It's got some of the firmware features of the ACH580, but not all of them. You're more likely to see this type of drive come in on OEM equipment. It's a little bit lower cost than the full functionality of the ACH580, so OEMs will gravitate to that unless you tell the OEM otherwise. And this drive is also compatible with the EC Titanium motor. It does go beyond 10 horsepower, but it does not go up into the hundreds of horsepower like an ACH580. And then the third offering on this slide here is the EC Titanium. So there's really a couple different ways EC Titanium get looked at. First off, I should mention EC Titanium is a new cutting-edge motor technology. It's a ferrite-assisted synchronous reluctance motor. It's better than IE5 efficient. Basically, it's IE6 efficiency, except the IE6 efficiency standard doesn't even exist yet. So this is more efficient than the most efficient standard that's out there. So that's pretty neat. Then when I take a look at packaging, I've got just the motor itself. So this is the one where if I have an ACH580 or an ACH180 VFD, it's going to run this motor right here. Or I can get this motor packaged with the drive, either on the end, like this one right here, or up on top. So essentially what you're looking at here is a motor with a micro drive built into it. With the drive built into it, it's available up to 10 horsepower. If you go with the motor only, it is available up to 20 horsepower. Transitioning over to the hardware differences between these drives, let's start out with the ACH580. So in the next couple slides, what you're going to see is I'm going to start with the ACH580 on a specific topic, transition to the ACH180 on that same topic, and then wrap up with the EC Titanium on that equivalent topic. So first slide here, we're talking about power options. So ACH580, a lot of different ways that drive can be packaged. I can get it with a breaker, I can get it with a bypass, I can get it with a DVDT filter if I got longer cable distances, I can get additional harmonic filters added with it. I can have a redundant drive package where I put two drives in a box. So a lot of different ways that you will see this drive package. Standard offering, those images on the right are just standard ABBO product offerings right out of the price book. You can get these in a UL Type 1, Type 12, Type 3R, 4, or 4X enclosure. So a lot of options there based on where you're going to be mounting that drive. With the ACH180, there aren't any power options available at all. I can't get it from ABB with a breaker or bypass. Really, it's meant to just be a simple IP20 drive, so it's typically going to be mounted in somebody else's panel right on a piece of OEM equipment, whether that's a pump panel or an air handler. So very simplistic as far as options. There just are none, and it's because it's meant to be a component that is going to be installed into a panel, and then if a bypass or breaker or other things are needed, they will be in that third-party produced panel, usually from an OEM. And if we take a look at the EC Titanium, I have an acronym there, IMD, Integral Motor Drive, just letting you know that when I'm talking about the EC Titanium today, moving forward, I'm going to be talking about the ones with the drive built into it. So when I look at that picture, the one on the far right, the one on the far left with the drive built in. So when you have the drive built in on the EC titanium motor, there's no power option, so I can't get a circuit breaker or any of those harmonic filters or something like that. It's all going to have to be external from the drive itself. The drive portion is an IP55, so roughly a equivalent of a NEMA or UL Type 12. Speaking of package drives with the ACH580, let's see how it impacts the short circuit current rating. Nearly all of the packaged ACH580 drives come with a 100 kA short circuit current rating because they have fuses built into the package. If you have a drive only, so a drive module, you can still get a 100 kA short circuit current rating, but it requires that fuses get installed upstream of the drive or maybe in a little fuse box right in front of the drive. Otherwise, for OEMs who are packaging the drive in their own enclosure, there are options to use a circuit breaker in front of the drive to get a 65 kA rating. So nice, strong SCCR ratings. 100 kA for commercial HVAC is more than you're ever going to need. Typically, anything 65 kA or above, it will take care of you. Now, with the ACH180, it's a little bit similar to the drive only, where if I include fuses upstream of the ACH180, I can have it as a 100 kA short circuit current rating. If I have a particular MMP, I can do 65 kA, so nice, strong SCCR ratings there. And wrapping up with EC titanium, it's a little bit different animal here. It only has a 5 kA short circuit current rating. Now there is a UL standard for air handlers, UL 60335-2-40, that does have an exception for what they call ECMs, not requiring to have an SCCR. That's in the current version of that standard today. I think long term that standard is probably going to have to change because that just, to me, it's a safety concern to exclude an SCCR altogether. But just be aware if you're looking at air handlers, sometimes you can get around the SCCR rating just because of this UL standard. But again, if it's me, a stronger SCCR is going to give you just generally a safer package. Looking now at the control differences, I'm going to focus specifically on inputs and outputs. So on the right side there, I've got a schematic of the ACH580. If you counted up all my analog inputs, analog outputs, digitals, and relays, you'd see that I have 2 analog inputs, 2 analog outputs, 6 digital inputs, and 3 relay outputs. So a lot of flexibility there, especially with the relay outputs. Those are Form C relays. Analog inputs are things for, like, say, either my speed reference could be coming into that. I could be getting a pressure or temperature sensor feedback. Maybe I'm doing all the control with the drive itself. My analog outputs could be something as simple as a integration back to the building automation system, letting it know how fast I'm running. Or it could be something more control related. Maybe I'm controlling the actuator for some mixed air dampers. So I can do a full control with the drive by leveraging those analog ins and analog outs. If those 2 AI, 2 AO, 6 DI, and 3 RO weren't enough, we have additional option cards that can be plugged into the ACH580. So depending which option cards you choose, you might use one that gives you the 3 additional AI and 2 additional AO, or one that gives you 2 relay outputs. There's one with a digital output on it. Even one that can let you interface into legacy systems that have 120 volt control, and then you can land the 120 volt right on the drive for things like your start stop or a safety signal. If we go over to the ACH180 schematic now, if you look at that one, I've got 2 analog inputs, 1 analog output, 4 digital inputs, 1 relay output, 1 digital output. So less than what you had in the ACH580. We're dealing with the micro compact drives now, so it's going to have less I/O. You'll notice I have the little asterisks there by the 2 and the 4. So one of the inputs are programmable to either be an analog input or a digital input. So if I had a situation where I needed a 5th digital input and I only needed 1 analog in, I could set up that drive to be 1 AI and 5 DI. So I could either be 2 analog inputs with 4 digital inputs, or I can redefine one of them so it's only 1 analog in but gives me 5 DIs. So you've got a little bit of flexibility there. Do note there's no option cards on this drive, so you can't take an accessory card, plug it into the drive to get additional I/O. So what you see is what you get on this drive for the analog ins and analog outs and DIs and ROs and whatnot. We wrap up with the EC titanium on this topic, the integral motor drive solution. By default, you've got 1 analog in, 1 analog out, 3 digital in, 1 relay output, so even a little bit less capability there. And like the 180 though, one of those are flexible, so I can reassign one of those inputs and get myself a second analog input, but I'd have to sacrifice a digital input, so I could do 2 AI and 2 DIs. It really depends on the application, what IO you need, so there is some flexibility there for one of those inputs. But unfortunately, like the 180, there's no option cards where I could plug it into it to get additional control out of it. So the 180 and the EC Titanium are targeted more for a very basic application, where the 580 can do the basic application and much more above and beyond that. With the communication protocols, the ACH580 will give you 4 embedded protocols. So you've got your typical BACnet MSTP, Modbus, N2, and GP1, General Protocol 1, which happens to work with the Siemens FLN networks. If you have a protocol different than one of those 4, there's a option card slot in the ACH580. So the most common one that we'll see will be BACnet IP, but also there's an option card for LAN networks, Ethernet IP, Modbus TCP, and several other communication protocols. So you've got flexibility in what the drive can take as embedded, being built-in protocols, in addition to what can be added to the drive via an option card like BACnet IP. The 580 can support 2 communication protocols at once. So I could be talking, say, BACnet MSTP to my building automation system, and then Ethernet IP to an energy management system. So it does support communicating on 2 protocols at once. ACH180, it has 4 embedded protocols, just like the ACH580. It's got BACnet MSTP, Modbus, N2, and GP1. However, there are no additional option cards available, so it's those 4 only that it supports. It cannot support, say, a BACnet IP or a LAN network. The EC Titanium is even more simplified. You've got BACnet MSTP, which would be typically to the building automation controller, or Modbus if, say, you had a unitary controller on that unit. So BACnet MSTP and Modbus are the 2 protocols that the integral motor drive EC Titanium supports. And then there are no additional option cards that can be plugged into it. So it's those 2 protocols or nothing. Now we'll talk about harmonic mitigation for a bit. Don't worry, I'm not going to do a full deep dive IEEE 519, what are harmonics and their solutions type of a presentation. We have plenty of those already, so if that's what you're interested in, just reach out to us. We'll hook you up with the right presentation. What I want to do here is just kind of compare the harmonic mitigation, the hardware involved between the 3 different drives. So starting with the ACH580, it's got a DC bus choke built into it as standard, 5% equivalent impedance. That's usually going to get you in that 35 to 45% total harmonic distortion of your current. Looking at THDI, total harmonic distortion of your current, is usually the best way to compare one solution to another as far as that first trying to compare apples to apples. There is a version of the ACH580 that comes in the ultra low harmonic flavor, the ULH. That's an active front end solution that gets you THDI all the way down to 3%. So quite popular for things like hospitals, data centers, or very large commercial buildings where they got a lot of VFDs in their mechanical room and large horsepowers, high quantities. Then they start looking at ULH drives for the larger sizes. Now taking a look at the 180, the ACH180, it's got no built-in DC bus choke, no built-in AC line reactor. As a result, you're going to see harmonics at least double of what you'd see out of the ACH580. So harmonics are bad, so doubling it is bad. You can add an additional AC line reactor in front of it, so that's going to be a separate device that gets mounted in the same panel as the ACH180. For ease of specification, typically though, ACH580 will get chosen just because it's all in one solution with the DC choke is built in, opposed to having to deal with multiple components in your electrical panel. But that is a solution for the ACH180. You can add a reactor in front of it if needed. And then wrapping up with the EC Titanium, that's just like the ACH180 in terms of there's no built-in DC bus choke, there's no built-in AC line reactor, similar performance as about double of what you'd see out of the standard ACH580. You can add an AC line reactor in front of most of the EC Titanium sizes, but there's, I know, at least one size that's got the thin film caps in it that don't play well with AC line reactors. So if you've got an EC Titanium with the integral motor drive and you do need to add a reactor in front of them for harmonic mitigation, be sure to coordinate with the factory personnel to make sure we have the right combination of reactor and drive size. Now let's look at redundancy and bypass and what our options are here. So we'll take a look at the ACH580. It's available as a bypass package. I will note there, assuming the motor can run directly across the line, DOL, direct across the line. Note that this EC titanium motor, this ferrite assisted synchronous reluctance motor, really high efficient motor, that type of motor does need to have a drive on it. So that motor cannot run across the line. If you've got 480 volt 3-phase, you cannot run that motor directly off that. You have to have a drive. So while the ACH580 is available in a bypass package, that's assuming you're going to be using like an induction motor as your motor, not a permanent magnet motor or a EC titanium style motor. But you can get a 580 with a bypass package. It's also available as a redundant drive package. So if I had the EC titanium motor only without the drive, so I had the motor only EC titanium, and I wanted a lot of redundancy because of a critical application, one option would be the redundant drive package, where I basically have two drives, and one's a primary and one's a backup. And if the primary is to fail, it can transfer over to the backup. So those are for, again, your hospital type applications where redundancy is important. And both the bypass and redundant offering is a standard offering in the ABB price book. It's not custom. It doesn't have some abnormal lead time or anything of that nature. If I look at the 180, the ACH180, there's no standard offering for a bypass or redundant package. At least from ABB, nothing really stops an OEM or a panel shop from putting something together, but there's no ABB standard offering for a bypass or redundant for the 180. Now, if you're looking at something like a fan array application, though, sometimes you just get redundancy naturally in the design, where I could maybe do one drive per motor. And that way, if one drive failed and I had enough oversizing in my fan array design, I could still limp along with the remaining fans and drives running. So you can get redundancy in that manner. And similar with the EC titanium, there's no offering for a bypass or redundant drive package. It's one drive on that motor, and the motor itself can run across the line, so bypass would never make sense in the first place. And similar to the ACH180 concept, is you can design in redundancy into your system, like with that fan array, having one integral motor drive package per fan, which is what would it naturally be, gives you a good degree of redundancy from if the electronics failed in one of those, naturally you'll have the remaining fans and motor drive packages that would be able to run. Now we're going to take a look at usability experience with these different solutions. So this is about the owner, the maintenance manager, the technician who's actually going to be in front of the drive, in front of the motor, and has to set things up, commission them, troubleshoot them, those type of activities. So starting with the ACH580, really the focus here is going to be on the advanced control panel that comes standard with that drive. It comes with the default one, comes with Bluetooth, but if you choose not to have Bluetooth, there's an option to have a non-Bluetooth panel also. Within that control panel, it's an alphanumeric control panel, so everything's in plain English, very easy to read. My favorite part about this is the primary settings and how you navigate around to set things up. You don't have to memorize a bunch of parameters. You just naturally gravitate. It's almost like I always refer to it as my iPhone, where my iPhone doesn't have a bunch of settings on it. I just kind of work my way through to general and find what I'm trying to look for. Same thing with this drive with the ACH580 and that control panel and primary settings. Very, very easy drive to use, set up, commission. And even some of the troubleshooting, it makes it a lot easier as far as the real-time clock and the event logger, and we'll get into those details in a little bit. On the bottom of the control panel, there's an interface for a USB interface, so you can plug in a USB and connect your laptop right to it. So if you're somebody who wants to see everything at once or download parameter sets and have a backup or send a copy to the owner or to the factory as part of troubleshooting, very easy interface to that control panel from your laptop using the Drive Composer tool. There's also a help button right on there. So if I'm on something I'm not sure on what a fault or a parameter, if I hit that question mark, it can give me some details about that. So it's almost like having a built-in manual right in the drive. So that help button is pretty cool. And it's got a handoff auto functionality at the bottom there. So you got a red box around some of those buttons there. So hand off auto, kind of a traditional user interface for HVAC. I also like the fact that the drive settings can be all stored to that panel. So let's say I commission this drive, it'll automatically back everything up to that panel. And let's say 8 years from now, there's a lightning strike and just goes through and takes out a bunch of electrical equipment in the building. And this ACH580 gets replaced with a new ACH580. Well, I can take that control panel off the original one, stick it into the new one, and dump all the parameters into the new drive and make commissioning a breeze. And then the other part about that is it's an automatic backup also of those parameters. So some of the older drives, like we used to have the ACH550, you had to manually do that backup. The 580, if you don't do the manual backup after an hour, it will do a backup all on its own. So a really cool feature on it. So the control panel in the ACH580 is absolutely top notch and makes this drive easy to use. If I dive into that primary settings a little bit more, one of the items within the primary settings is the HVAC quick setup. So as an example, in my younger days, I used to teach a whole lot of authorized startup classes to my channel partners, to controls techs, to mechanical contractors. And at the end of every class, they'd always say, hey, Tim, we went over a lot, but can you give me like the top 5 or top 10 things I'm always going to have to program on this drive? And back then it was the ACH550 days. So what we did is when we developed the ACH580, we took that top 10 concept and put that right into a menu called the HVAC quick setup. So you don't have to go through an assistant or a wizard or any of that. You can just go right through this HVAC quick setup list, and boom, boom, boom is going to ask you all those common things. Hey, where's my start stop landed? Do I have any safeties? What's my motor data? How fast do I want to be able to run? Am I running a 0 to 10 or am I running a 4 to 20 milliamp signal? What's my control signal? So really easy to set up this drive, all because of the advanced control panel that comes with this and the primary settings firmware behind that hardware control panel. Another neat part about that control panel is graphical. So I can trend things, whether it's a 15-minute trend or a 24-hour trend. I can show information in different ways. This can also be really helpful in troubleshooting. So I can see what's been going on. If I've got a really advanced building automation system, when I say advanced, I mean really well integrated into the drive, a lot of times I can see these things through the automation system if it's trending the things at the frequency I want. But a lot of times, unfortunately, they're not fully integrated to that level. So you've almost got a little mini building automation system right in the drive. So you can do things like trend data over time, which can be beneficial for troubleshooting. It's also really handy to have for when you're doing things like doing an energy study and how much energy your building is consuming. Outside the fact that there's a whole bunch of energy meters in the drive itself, you can trend power consumption over the course of the day on all of your equipment that are using these ACH580s, and you can see in a graphical format. So the more information, the more knowledge you have, allows you to have better decisions about how you want to save energy and what your approach is going to be. Looking at the ACH180 solution for a control panel, by default, it comes with an integral control panel, so it's not that same control panel that we just saw on the ACH580. By default, it comes with this integral control panel. It doesn't have as much alphanumerical, it's not graphical, so it's still helpful. You've got something, but a lot of times if you're going to use this panel above and beyond just looking how fast it's running and start and stop and things like that, if you're going to do any kind of adjustments, you're typically going to want a user manual in order to define what some of those parameters and settings are. So just kind of an example there. I'm going to take a look here, and there's a lot of symbols that also get used. So where you see that number 1 on the right side there, that's a picture of a motor. So if I selected the motor image, that's going to take me into the motor data, the motor parameters. So if I hit OK on that, went another level deeper, it would look like this image right here. So I can see, hey, it's an asynchronous motor. It's in scalar mode. It's 0.75 kilowatts, it's 1.9 amps, it's a 400 volt motor. These are all things that have been set up in that, configured for that motor when programming that drive. So you can still kind of figure it out. It's just not quite as clean as the full function alphanumeric ACH580 control panel, excuse me. However, if you do like that ACH580 control panel, it is compatible with the ACH180. It's an additional panel that gets mounted remotely, so you have to mount it on the outside of a panel or somewhere. So you'd still have the integral control panel in addition to this external control panel here. And similar to the ACH580, you can still connect the ACH180 to a laptop. So if you're the person who likes to interface with laptops to devices, the 180 can support that too. The EC Titanium does not have an integrated control panel on that integrated motor drive package, which makes sense because a lot of times this motor drive package may end up somewhere like, say, inside of the airstream of an air handler. So it doesn't make sense for you to be trying to stick your head inside of an air handler while it's operating to see what is being programmed or what is being displayed on that particular unit. So you do have a couple options though for that user interface to this package on the EC Titanium. One is there's the optional Bluetooth, just like the ACH580 and the 180 if you get the upgraded control panel that gets mounted remotely. This package can also have Bluetooth on it. You can connect the laptop to it, so you can gain access to it. You can go ahead and plug in a laptop and see all the parameters right on the software tool on your laptop. Alternatively, you can get a remote mount control panel. So there's a 7-segment display here that you see on the right. It's similar to the ACH180's integrated control panel where you've got a lot of simple one letter and some digits after it. So you got codes and things like that. There's a few words on it. So just as an example here, if we take a look at the red text, yes, it might say something like stop or standby, but also if I was trying to see the status and going through and I cared about output frequency or output amps or output kilowatts for the power, it might be H and then for hertz and then the number, and then A for amps and a number, and P with a number afterward. It's just not quite as intuitive as you would get out of the advanced control panel. If you did want something very intuitive, easy to use, graphical, that's when you're looking at something like an external HMI and connecting that in and you having that be your interface to the EC Titanium. Now we're going to talk about some of the various features, and a lot of it is going to be firmware. Not everything, but a lot of these will be firmware features, but just general application features. So as we go through these next couple slides here, first I'm going to say that this recording was done in mid-2024. ABB continuously improves our products and our firmware, so there might be something down the road that a drive may not have today that it may get in the future. So just be mindful that as of the time of recording is when everything here is factual. And the way I'm going to do this is I'm going to have a topic, then I'll have columns there on the right for ACH580, ACH180, and EC Titanium. If it's a green checkbox, that means, hey, that's how the drive comes by default with that functionality. If it's a red checkbox, it's going to mean that it's an ACH180 related item that needs to be upgraded to the full function control panel. And if it's a blue checkbox, it's got something similar to that functionality, but just maybe not quite as full featured. So I'm going to have quite a few of these I rattle off. If you got questions on these, reach out to your local ABB specialist. They can give you a lot more details on any of these individual topics. But starting off now, proof of flow concept, or if it's a fan application, maybe a broken belt. All three flavors have that, although the 580 and the 180 support the pumping situations for proof of flow a little bit better than the EC Titanium. But the concept of a supervising of current or torque is capable of all three of those drives. Motor disconnect detections in the 580 and the 180 makes sense. It's not in the EC Titanium since there is no possibility to put a disconnect between the motor and the drive in that case. You've got intelligent pump control. It's a feature in the ACH580 that allows me to have multiple drives talk to each other, say on a pump skid application, and turn drives on and off as needed for the system to operate and maintain pressure. That's only an ACH580 feature. You've got advanced damper control. Now, any HVAC drive should be able to control a damper. Hey, I'm giving the drive run command, fires a relay to go ahead and tell the damper to open, waits for an end switch to come back to the drive, and lets the drive run. I'm not talking about that. When I say advanced damper control, I'm talking about maybe a damper on both sides, supply, discharge, air type dampers. I have to sequence them, have this damper start first. Maybe I need to pre-pressure it before I start opening because I don't want back pressure to make my fan run in the wrong direction. So the ACH580's got a lot of flexibility there as far as the damper sequencing. And then the concept of controlling an entire air handler, that again would be more of an ACH580 functionality. We talked about a lot of the inputs and outputs earlier as far as the analog ins, analog outs, digital ins, and all of those things. So that I/O, along with the firmware that supports it, really lets you run an entire air handler with the 580. Part of that, and tied to that running an entire air handler, is you need to have some PID loops. So all of three solutions have internal PID functionality, so I can take a feedback device, give the drive a set point, and have it run, speed up and slow down to hit that set point over time. The 580 separates itself by having the external PID functionality, where I've got 4 external PIDs. That's where I can control mixed air dampers, chilled water valves, hot water valves, bypass valves on a cooling tower. That's where the external PIDs really shine. And that's a 580 function only. Plain English interlock text, definitely the ACH580. I can have something assigned to a safety like high static safety, so that way if that safety ever opens up on the drive, it actually says high static right on there. There's some of that flexibility on the ACH180 if you upgrade to the full functionality on that control panel, but not quite as good as the 580. So that's why I gave it the red checkbox saying if you want any of that at all, you need to upgrade to the advanced control panel. And the blue checkbox means, hey, it's still not quite as good as the 580. If you want to customize any text, so you want to assign text to a certain safety or interlock and have it say exactly what you want to say when that safety opens, the 580 supports that, and the 180 will support it if you use the upgraded control panel. If you want a real-time clock, so that way if I have something happen, drive fault, it'll tell me exactly what time that faulted. Great for troubleshooting. The 580's got it. The 180's got a real-time clock if you upgrade to the advanced control panel. If you want full graphing trending capability, again, 580 has that. The other ones do not. If you want BACnet IP compatibility, so integrate to a building automation system with BACnet IP directly at the drive, that would be an ACH580 only. The 180 and the EC Titanium can both also do BACnet, but they only do BACnet MSTP. How about that user interface as the handoff auto functionality? The 580 and the 180 have buttons that are labeled handoff auto as far as being able to go from one mode to the other, where the EC Titanium is more of a start-stop interface if you have that 7-segment display control panel. But again, it doesn't come with an integral panel, so it really comes down to what control you're going to put in front of that EC Titanium for your HOA. But the 580 and the 180 have HOA functionality integrated into it by factory default. 580 and 180 also have a feature called checksum. So with security becoming more popular and more important, I should say, as drives get commissioned, if you ever want to know if somebody came in and changed something after the fact, there's a checksum value that would change after the drive had a parameter adjusted. So the 580 and 180 will both let you know that somebody had changed a parameter after it was originally configured. I/O menu. So this is a really cool feature that lets you take a look at all the statuses of your inputs and outputs on a single screen as far as, hey, what is my input program for and what is the current value. So I can see my analog input 1 is my speed reference, and I can see it's at 7 volts coming into it right now. So excellent way for troubleshooting. You don't have to get a multimeter out and figure things out or go navigating into parameters. The 180 and EC Titanium, you can get the same type of information if you're navigating through things, but the 580 really makes it easy for you to get on a single I/O menu. DC bus ripple, that's a feature that all three of these drives have, so I think that's pretty cool. That lets you know if you've got some power quality issues where maybe your phases are imbalanced, you can take a look at your DC bus ripple. HVAC quick setup, I talked about that a little bit earlier today as far as being able to have your top 10-ish parameters that you like to set up in the drive in a single list there. You've got your primary settings, which I compared that to my iPhone as far as being very easy to go ahead and navigate and find things. Although thinking of all the Android users out there, maybe I need to stop talking about my iPhone example. But if you're an Android user, think of it like your Android and easy to navigate to things. Eclipse bypass compatibility. So that's also an ACH580 only function. So if I wanted to get a bypass from ABB, it's going to be an ACH580 package. But again, note the EC Titanium motor, only that motor technology can't run in bypass. So the Eclipse bypass is really for induction machines, induction motors. Another neat thing that all three of these drives have is if it's a 0 to 10 volt or a 4 to 20 milliamp selection, You choose that analog input via parameter. There's no dip switch needed to flip. Dual comms capability. So backed in MSTP and Ethernet IP at the same time. The 580 would be able to do that, while the other ones cannot, because the other ones don't have option cards to plug into for integration purposes. It'd be just what's embedded. Motor heater functionality. So maybe I got a cooling tower and it gets cold at night and warms up in the morning. You don't want condensation to form. The 580 and the 180 have motor heating functionality built right into them to electronically heat your motor, so you don't need an additional motor winding heater. As far as which is going to have your lowest input current for the equivalent horsepower size, as far as what's truly drawing, that is going to be the ACH580. And that's because of the fact it has a DC bus choke built into it. So it's going to have a lower RMS input current. So that means less losses in your system, your I2R losses over your power wiring. In some cases, you might even be able to use a smaller size wire compared to, say, an ACH180, just depending on the situation. So the 580's got your lowest input current rating of the three. And for the OEMs out there, that helps with things like MOCP, MCA calculations also, because that's all changed to based on the input current of the drive opposed to what used to be the output current of the motor rating. Touched on it a couple times, but again, just to reinforce it from a usability aspect, includes an integral control panel as standard. The 580 and the 180 both include a control panel as standard. The EC Titanium does not, but it does have a remote mount option that you can order. This next one here, you'll notice my green checkbox in the top middle there is a little bit different green. So as of the time I record this right now, the 180 does not have this, however it is planned. So this top line is multiple ratings. A neat item that you can do with the 580 is you can re-rate it. So let's say I have a 10 horsepower drive, but it's only ever going to get loaded at about 75%. So really the equivalent of 7.5 horsepower at that point, right? So if it's only getting loaded at 75%, then I can lower my input current rating by 75%, which also lets me even further reduce the wire sizes, fuse sizes, upstream electrical protection devices. So multiple ratings. There's an entire webinar on that, entire technical note on it. If you want to learn more, reach out to your local ABB person. We'll hook you up. But just know today, as I record this, the ACH580 is the only one that has that multiple rating capability. Being able to name the VFD. So maybe I'm supply fan 2, or I'm pump 3, or chilled water pump 2A, or something like that. On that advanced control panel, if you've got that advanced panel, you can actually name the application, that top middle of that control panel. It's customizable. Really cool item. Contact info on a fault. So if the drive was default, you can program in the drive exactly who to call when there's a problem. Local folks love that, because then instead of having to find the 1-800 number to call up the ABB factory, if this happens at your facility, you'll have the local ABB channel partner may have programmed their local number into there for you to call them. So the 580's got it, the 180's got that if you add the advanced control panel. This next one, you'll see I put a new symbol on here. It's a green X. So this is for Buy America, Buy American. One thing I know about the government, the U.S. federal government, is nothing is ever the same long term. There's always redefined things depending who the administration is. Policies change. So I'm just going to call this a green X. So I will say that the ACH580, that's built at the factory that I'm based out of in New Berlin, Wisconsin, and the EC Titanium, that's all built and packaged in the United States. So depending what the rules are of the current administration and what we're talking about, Buy America versus Buy American, or any of the other policies out there, there's a very good chance that the 580 or EC Titanium will be able to comply with that. Just need to circle back to the local experts and figure out exactly which standards you need to meet and verify that that particular drive meets it. ACH180, that's made offshore and comes to the U.S. from overseas, so that one's not going to meet any kind of Buy America or Buy American clause. As far as running EC Titanium motors, figure I just put that in there as a reminder. So EC Titanium, the motor only, it's a special, unique motor. Obviously, the EC Titanium with the integral motor drive has the right algorithms to run that motor. So does the 180 and the 580. The last one there, horsepower range. If I didn't put the specific horsepower range in here because I don't want anybody to memorize a bunch of numbers, just know that the 580 goes much larger horsepower range compared to the 180 or EC titanium. Now taking a look at enclosure options. Mentioned earlier, you got your type 1, 12, 3R, 4X, a lot of flexibility with the 580 as far as what type of enclosure that you can put in. 180 doesn't come with anything other than the IP20 enclosure. There's a type 1 kit you can get, but again, that's usually going in somebody else's panel. EC titanium just has its one standard type 12 equivalent rating. It's usually because that's all you really need because it's in the same environment where the motor is going to be. Warranty, we'll talk about that more in a little bit, but the 580 gets the green checkbox there compared to the other ones. Physical size, that's going to be where the 180 and the EC titanium are going to shine. The EC titanium's got everything in an all-in-one solution, or if we're just comparing the 580 to the 180 is going to be a smaller size. There's a reason they call them compact or micro drives. Spare parts, that the win goes there to the ACH580 as far as flexibility, as far as the different types of spare parts that are available, where the 180 and EC titanium are more of the electronics portion, are meant to be more of a throwaway when there's a problem. Override mode, some people might call that fireman's override. All three drives support that, so they're all meant to be in HVAC life safety type applications. And adaptive programming, the traditional ABB adaptive programming is in the 580 and the 180. Wrap her up here with a couple more. So we take a look at sensorless flow calculation. That's a 580 function only. So I can estimate how much flow I have based on feedback coming back to the drive. There's also sensorless pump control. This is more of a feature that OEMs use. It's not really meant for field retrofits, but you can do sensorless pump control with an OEM. So that way they don't need pressure transducers 2/3 of the way down the line. They can put pump profiles into the drive. So those two items are 580 only. Safe torque off. So this is a little bit more popular for the refrigeration side of HVACR, the R side of it. The 580 and the 180 both have that. Local stock by channel and distribution. So this one is going to be kind of case by case as far as where you're located and who your local folks are. But the ACH580, I can confidently say pretty much every US-based HVAC channel partner or distributor is stocking ACH580 drives. The 180 is kind of case by case, and EC titanium, again, case by case, who your local folks are, what sizes exactly you're looking for. And last but not least, reference to scheduling here. So I mentioned earlier that the 580 and the 180, if you upgrade the control panel, has a real-time clock on it. So that allows you to do things like scheduling. So you can almost do a mini building management system right in the drive and say, okay, Mondays through Fridays, I'm going to have this fan run from 6 a.m. to 8 p.m. On Saturdays, I want this schedule. On Sundays, I want that schedule. And based on this year's holidays, I want these days to be exclusion days where it follows a different schedule. Those are all things that can be done in the 580 or the 180 if you upgrade the control panel because of its real-time clock capability. Now we've got the installation and application of these products. So this can almost be a bit of an integral versus discrete mounted drive. So either the integral or integrated motor drive combination versus a loose drive and motor. And you could almost say some of these might apply to ECMs also, traditional ECMs. However, I will say that the EC titanium is a heck of a lot better than your traditional ECM as far as some of these topics we're going to talk about over the next couple slides. So for this example, let's just assume a fan array. I've used that example a couple times today. We'll just stick with it. So first thing to consider is the mounting location. So if I look at the image on the right there, I can have a fan array and I can have one drive with an integrated motor drive and fan for each cube on my fan wheel and fan array. And that drive is essentially going to be in the Airstream. So it's a little bit harder to get at, harder to program those type of things. But a lot of that gets done at the factory, so there's not a whole lot of field work that needs to happen anyway there. And then you've got the discrete drive and motor where you can pretty much mount that drive anywhere out. So it can be in the Airstream if you want. It does not have to be, and usually I recommend don't put it in the Airstream if you don't have to. So if I start out looking at that integrated motor drive solution, it's basically in the Airstream. So whatever my fan array air temperature is what I'm being exposed to. So If I'm a nice solid 55-degree discharge air temperature and that's all that unit ever does, that's not a bad environment for that drive. If I'm in a situation where it might be a staging solution, it might go from nice 55-degree cool air to somebody opening up a service door and now I've got 105-degree air that's horribly humid and everything condensing in there. Yeah, it's not a good situation. So you got to kind of consider that environment. Maybe if I'm in an air handler and it's got a heating mode and I'm going to be discharging 100 and some degree discharge air out of that air handler in heating mode, yeah, that puts that drive in a warmer environment. So just kind of consider the airstream you're going in, if it's going to be anything corrosive in it, if the temperatures are going to ever be exposed to some extremes or not. If so, then it's more of a reason for you to mount the drive away from the airstream, that's where you want to go with that discrete drive and motor. There's the upfront cost aspect of looking at these solutions. Generally speaking, there are a lot of variables out there, but a lot of times that integrated motor drive combination, that EC titanium, is going to be a lower upfront cost compared to the discrete drive an EC titanium motor only solution. And where that comes in is just that upfront wiring, installation, everything is that all-in-one package. A little bit easier for the OEM when they're including that. They don't have to worry about the driver, that coordination. Now, that's upfront cost. In a little bit, we're going to kind of talk about the back end cost because that's a totally different story there. And I've mentioned packaging a couple times, but again, just to bring that up, especially with that discrete drive and motor solution, you got flexibility in the enclosure rating. You can get a disconnect on it. You get harmonic mitigation, so you got a lot more flexibility on that discrete drive and motor from the packaging aspect. When it comes to serviceability, now we take a look at, okay, what happens if there's a problem? Let's say it fails. If you're in charge of a facility, you're the facility manager, you're in charge of service, making sure that everybody's happy. Usually the folks like you are going to gravitate towards that discrete drive and motor. Let's say, for example, that ABB drive fails on the discrete drive and motor, that loose drive, and you're not happy with the ABB. Or my lead time just isn't quite as fast as you want, or the horsepower size you want, that specific one's not available locally in stock. They got the one in stock, but it's one size too small or something like that, and the other one is slightly back ordered, and you need that unit up and running. You don't have to use another ABB drive. You can basically buy a different brand of drive and install it in there, and it's usually a pretty quick and easy integration. When you look at the integral motor drive solutions, that's where it's a little bit tougher to swap from different drive brands. In the case of the EC titanium, you'd essentially have to take that drive off of there, then find a different drive from a different manufacturer and find a spot to install that, move all the control wires. It's a pain. It's not easy to do. So you're a little bit more locked in to ABB as your vendor, your supplier, when you go with that integrated motor drive, EC titanium. Or if you go with the discrete drive and motor, the loose drive and EC titanium, you've got more flexibility there. Because if I ever make you not happy on the drive side, you can go elsewhere and it's not going to be that challenging for you. So a lot more flexibility when it comes to servicing the discrete drive and motor. Same thing on the spare parts. There is more spare parts available for that discrete drive and motor solution compared to the EC titanium with integrated drive. And then along those same lines, the troubleshooting side of things, with the loose drives, you just got that advanced control panel on there. You can see exactly what's going on. You've probably got similar ABB drives on other equipment, so everybody's trained on how to use those. So a lot of times you've got that, it's easier to troubleshoot. There's also local expertise with that integrated motor drive, EC titanium. Usually you're going to be calling the motor guy up for support. Motor guys know the motor side of things a little bit better than the control side, where if you call up a drives guy, they know the control side and the drive. So sometimes you get something that's a little bit of a mix of a drive problem and a controls problem. More times than not, you're going to get a little bit better support from the drives guy than the motor guy. But again, I'm making some really big general statements here that may not be true in your specific area. So I'm going to rely on you to know who your local motor and drive experts are and rely on who you trust. Next topic is redundancy. So take a look at this image right here, and just wanted to share that you can have, and this drawing here is really assuming induction motors, But when you have loose drives, you've got really 4 different designs you can do with a fan array. You can do 1 drive per motor. You can do 1 drive with multiple motors. You can do a redundant drive, so a primary drive and a backup drive, or you can do a drive with a bypass. So today, again, as I record this, and ABB has a tendency to constantly improve things, with our EC Titanium, I can only run 1 with an ACH580. But down the road, there may be an opportunity for us to have 1 ACH580 run multiple EC Titanium motors. So we'll be taking a look at that. So with the EC Titanium motor, the bypass option will never be in play, but there's a chance some of those other 3 may be in play, specifically the top right and the bottom left. So those are things that all impact that upfront cost topic also. Stay with me now, we're almost done, but I do want to talk about spare parts and warranty. So we just got done talking about that serviceability aspect and how that may impact the decision of, say, a facility manager, a chief engineer who is responsible for taking care of things. Everybody loves the product until there's a problem. So then what do we do when there's a problem? So let's talk about the spare parts and warranty. So starting with the ACH580, again, I've mentioned this a few times, but just wanted to reiterate it. You got more flexibility when it comes to the spare parts. The image on the right there, that's the control board for the ACH580. If I have a problem, I can change out the control board, keep my power section, and get her up and running again. Also, the ACH580 is going to have the best warranty options out of the 3 options. So by default, it starts at 30 months from date of shipment. You can definitely get longer options beyond that, but just absolute minimum is 30 months from date of shipment. I do need to point out that's the U.S. warranty, so globally that warranty may be different elsewhere, but for the U.S. market, that's 30 months from date of shipment. And then that covers parts, labor, and travel, so all 3 of those parts. The ACH180, those compact, those micro drives, they're typically viewed as a throwaway device. They're not really serviced. They don't troubleshoot them a whole lot other than the cooling fan. The very small ones don't have a cooling fan. Bigger ones do, so the cooling fan can be replaced. But other than that, the control panel, it's integrated to it. So that's basically if there's a problem with that drive, it typically just gets tossed. And it's a 1224 type of a warranty. It's parts only. So when I say 1224, it's 24 months from date of shipment or 12 months from date of installation, whichever comes first. And again, it's parts only, so it doesn't cover labor or travel for that warranty on the 180. And then the EC Titanium. The one thing I really like about the EC Titanium is it gets compared a lot to ECMs on the market. ECMs are absolutely horrible when it comes to spare parts. Basically, if you've got a problem, the whole thing gets thrown away. The electronics portion gets thrown away. The motor portion gets thrown away. A lot of times, the fan portion will even get thrown away because it's all balanced together as a single cube. So when it comes to circularity and those type of things and what's good for the environment, ECMs are horrible. However, the EC Titanium is a lot better. The electronics portion can be replaced. So if I have the electronics portion fail on an EC Titanium, that's basically the drive, I can pull that portion out and stick a new drive on it. The traditional ECMs out there, if the electronics portions fail, they have a 10-cent capacitor go bad, you're now replacing a $4,000 assembly. So we don't have that problem with the EC Titanium. So it's something that I'm really happy that we're able to design that with our EC Titanium to have that drive portion be replaceable. The warranty on that drive portion is a 2-year warranty. The motor itself is 3 years, but the drive portion has a 2-year warranty on the EC Titanium. And then just wrapping it up, so thanks for staying with me here. So we had the ACH180, 580, and EC Titanium integrated motor drive or integral motor drive, depending who you talk to. 3 really nice solutions. Each have their own place. There is not a one-size-fits-all of saying always use this or always use that. That's why we have 3 different offerings at ABB. So there's the hardware differences, whether it's the packaging as far as the enclosure rating, the harmonics, bypasses if you had an induction motor, the amount of I/O you've got, the integration capability of it, the harmonic profile, a lot of hardware related things that kind of differentiate them. So figure out what makes sense for your application. There's the user experience where the ACH580 kind of wins hands down on that. The 180 gets close if you upgrade to the advanced control panel and mount that remotely somewhere. EC Titanium is really meant for having the OEM program and get it all set up for you, so when it hits the field, it just works. A lot of features we went through that are typical of drives. The ACH580 kind of won that if we're doing a comparison, but at the same time, not all those features are needed for every application. So again, it really comes down to what you need for your application. The installation and application of the three offerings, that really came down to, do you want the drive mounted on the motor? Or do you want the drive mounted loose? There's pros and cons to both. And really, if it's going to be on the motor, definitely consider the environment that that motor is going to be in, because sometimes it's better for electronics to be in a different environment from where the motor is, as far as, say, for example, is an air handler in a heating mode running at 105 degrees or something along those lines. And last but not least, the replacement parts and warranty. The 580 gave you the most flexibility there. And then similar to the replacement parts aspect is, if you had an issue with the ABB as a whole and you want to use a different vendor, whether it's lead time or whatever reason, you can always switch to another manufacturer if you have a loose drive, a discrete drive, and a separate motor. It's kind of possible with the EC titanium and to pull that drive off and put somebody else's drive in there, but it's a lot more pain out in the field than trying to figure out where you're gonna install it and how you're gonna get that wire all redone. So again, more flexibility if you're going with the loose drive, but each application is unique. I would highly recommend you reach out to your local ABB drive expert. They can talk through all these things with you and figure out what makes sense for your application. And with that, I thank you for attending the presentation. Have a nice day.